So in this video, you're going to walk away with a bunch more vocabulary words that have to do with angle relationships. These angle relationships are going to be formed because two parallel lines are going to be cut by a transversal. What you're going to have to realize is the two videos that we've been watching on angle relationships have a lot of vocabulary words. And these vocabulary words aren't just going to sink into your brain. You're really going to have to make sure that you start making study guides or flashcards that help you identify what each of the words mean. So as you're watching this video, it may help you to start that study guide and then just add the words that are at the end of the video and complementary onto that study guide. So we're going to extend our knowledge of angle relationships by exploring our new favorite diagram, which is the diagram where you see two parallel lines. Parallel means that they never touch, they go on forever. And it's intersected by what we call a transversal. And a transversal is just a line that intersects two parallel lines. And when two parallel lines are cut by a transversal, it forms 8 angles. And these 8 angles have special relationships that we're going to talk about in the next couple of slides. And those special angle relationships we're going to be able to create equations just like we did with vertical and supplementary complementary angles. The first type of angle we're going to talk about is called alternate interior angle. So here's our favorite diagram again. Parallel lines cut by a transversal. You see 8 angles. The alternate interior angles are the angles on opposite sides of the transversal that are inside the parallel lines. So when I say inside the parallel lines, I think about the parallel lines as slices of bread. So if I look at the slices of bread, my peanut butter and jelly or my roast beef is going to go inside the bread. So the interior angles are going to be the angles that are inside the bread. That would be 3, 4, 5, and 6. Alternate interior angles would be interior angles that are on opposite sides of the transversal. So if we look at these diagrams below, you're going to notice that 4 and 5 are alternate interior angles. They're on opposite sides of the transversal, inside the bread. Same thing with 3 and 6. Right? 3 and 6 are going to be alternate interior angles. Alternate interior angles are equal. They are congruent. So if we're given the measurement of angle 4, we know that's also the measurement of angle 5. If we're given the measurement of angle 3, we also know that's the measurement of angle 6. Our second type of angle we're going to talk about is alternate exterior angles. Again, favorite diagram. So that diagram are 8 angles. When we talk about exterior angles, we're talking about if the parallel lines were the slices of bread, where we would hold the bread. So in that case, the exterior angles would be 1 and 2, and the exterior angles would be 7 and 8. Again, alternate means opposite sides of. So for alternate exterior angles, you're talking about the two exterior angles that are on opposite sides. So 2 and 7 are alternate exterior angles. 1 and 8 are alternate exterior angles. So if we look at this diagram, 1 and 8 and 2 and 7 are alternate exterior angles. Just like alternate interior angles, alternate exterior angles are also congruent. So if we look at this symbol, that symbol means congruent. So it's an equal sign with a little similar symbol on top. That means congruent, and all congruent means is equal. We call angle measures congruent, and we use that sign to show that. The third type of angle relationship that we're going to talk about is corresponding angles. Our favorite diagram. Corresponding angles are the angles that correspond to each other, hence the name corresponding. And what that means is if I picked angle M off the page and I put it on top of angle N, the angles that would overlap each other would be corresponding angles. So corresponding angles have to be one angle on line M and one angle on line N. So in this case, 1 and 5 would overlap each other if I took line M and put it on top of line N. And 2 and 6, and 3 and 7, and 8 and 4. So if we look at the diagrams below, it's just isolated it for us. So 1 and 5 are corresponding, 3 and 7 are corresponding, 2 and 6 are corresponding, and 4 or 8 are corresponding. So because if I took the line off the page and light it on top of the other, they would be on top of each other. Corresponding angles are also congruent. So when you're thinking about all of these congruent angles, you should be thinking to yourself, if I had an expression for one angle, I could set it equal to the expression for the congruent angle and solve for x and the angle measure. In our previous video, we talked about supplementary, adjacent, and vertical angles, as well as complementary. But in this specific diagram, we can't really speak to complementary. So we're going to relate supplementary, adjacent, and vertical angles to this new diagram, which is now our favorite diagram. So when we look at the diagram, we just look at angle M, we can say that angle 1 and angle 4 are vertical angles. They're forming those same V's. There's two lines that intersect, angle M and line M and line T intersect and form 4 angles. Well, in this case, 1 and 4 are congruent and 3 and 2 are congruent. They're equal. And on line M, 5 and 8 are congruent and 6 and 7 are congruent. They're equal. We talk about the supplementary angles. We look at each line and we say, hey, there's a line like line M. That means 1 and 2 are supplementary, because if I covered up everything else, 1 and 2 would be on a line and they would add to 180. Just like 2 and 4 would be on a line, so they're supplementary. And 3 and 4 are supplementary, and 1 and 3 are supplementary. Same thing as 5 and 6, and 6 and 8, and 8 and 7, and 7 and 5. They're all supplementary. All the angles that I just mentioned that are supplementary are also adjacent, because those supplementary angles are next to each other. They're next to each other. They share a common side. The only angles that are not adjacent are those that are vertical. So 1 and 4 are vertical, they are not adjacent. 2 and 3 are vertical, they are not adjacent. 5 and 8 are vertical, they are not adjacent, and 7 and 6 are vertical, they are not adjacent. So we can apply 4 of the 5 terms that we learned on the last video to this diagram: congruent, supplementary, adjacent, and vertical. So a lot of times students ask me, Ms. Almeida, there's so many different congruent angles. Yeah, there are. Congruent angles are vertical angles, they're alternate exterior angles, they're alternate interior angles, and they're corresponding angles. All of those terms, if you read them in a word problem or somebody put them in a problem for you, you would be able to say, oh, okay, I can create an equation where one angle measurement equals the other angle measurement. The only times that you can't make one angle equal the other is if you have supplementary, which means that you would add the measure of angle 1 to the measure of angle 2, and you would get 180. Or complementary, where you would add the measure of angle 1 plus the measure of angle 2, and you would equal 90. So really there are only 3 possible equations that we can set up. We can set up one angle equal to the other angle, in which case they're either vertical or alternate exterior, alternate interior, or corresponding. We can set up supplementary, which would be the measure of angle 1 plus the measure of angle 2 equals 180. Or complementary, where the measure of angle 1 plus the measure of angle 2 equals 90. There are no other choices in these situations. And the only way they're complementary is if you see that there's a right angle that's formed by the bigger angle. And the only way they're supplementary is if they're on the same line, unless you're told that they're complementary, in which case they could be 2 different angles. But unless you're told they're complementary, you cannot assume by looking that things are complementary, unless there's a right angle box. Or if you're told that 2 lines are perpendicular. So you're either going to see a right angle box to know that they're complementary angles, or you're going to be told that 2 lines are perpendicular, in which case if 2 lines are perpendicular, you're going to see a symbol that kind of looks like an upside down T, in which case you're going to know that even if you don't see the box, that the box really does exist. And then if you know that these 2 lines are perpendicular, you know that whatever cuts the angle into pieces will create 2 angles that are also complementary.